Hello and welcome to this screencast video made by RC1151 SRM University. Our screencast is titled Measures of Central Tendency. So before going into the topic per se, I'd like to take a few seconds to talk to you about what is to follow. So following a very brief introduction, I'll try and define what is central tendency. Then I'll go into each of the three measures of central tendency, which are the mode, the median, and the mean. I'll try and define each of the three measures, provide a very brief explanation, and then we'll work out some examples in order to make the distinction between the three measures explicit. Right. So let's begin with the average. So all of us have heard of the word average being used on a daily basis, probably. So on an average, how many liters of water do you drink per day? Or what is the average income earned by a graduate of XYZ university? So when a common man uses the word average, what he's trying to do is he's trying to describe the group by a single number which he thinks is typical of that set of data. This, from a scientific standpoint, is not really correct. There's a degree of imprecision in the usage of the word average here, which means it's vague, and therefore this is also confusing. So in order to do away with all this imprecision and the vagueness and the confusion, we need to invoke the concept of central tendency. So this central tendency is something that is located towards the middle or the center of your distribution. So when you have a data point distribution, central tendency lies somewhere towards the center of it, because it is the center where most of the data is located in a given set of data points. So the common man uses the word average, and by the usage of that word average, he includes a lot of different meanings in there. So like we said, in order to do away with all of that imprecision in here, we'll note as we go forward that there are different kinds of measures of central tendency, and you'll also note that these different kinds of measures of central tendency, they take on quite different values in the very same data set. So the three best known measures of central tendency are the mode, the median, and the mean. So let's try and deal with each of these one at a time. So let's begin with the mode. So the mode is the most frequent or the most common value in a set of points. For example, if at a given college, if English literature is the most preferred major by the students, then English literature here becomes the mode for this set of data points. That means the mode is the only measure of central tendency available for nominal level variables, as in my nominal level variable here is the choice of the college major by the students. So like I said earlier, the mode is that number that occurs the maximum number of times in a distribution. So the good thing about the mode is that in order to find out the mode in a distribution, you do not have to do any calculations. You just have to inspect your set of data points and then see which is the number that occurs the maximum number of data points, and then zero in on that as your mode. So for this set of data points, if we want to find out the mode, we need to see which is the number that occurs the maximum number of times, and then we see that it's the number 2, which occurs 3 times. And because this is a single number, the number 2, which occurs the maximum number of times, this becomes a unimodal distribution. The important point to be remembered over here is mode is not the frequency of the most frequent score. So the frequency of my most frequent score is 3. So 3 is not my mode. The mode is 2, because 2 is the number that occurs the maximum number of times. So in this example, there are two numbers, 7 and 2, which occur the maximum number of times. Therefore, this becomes my bimodal distribution. Moving on to the second measure of central tendency, which is called the median. So all of us know what is a median because we travel by road. So this yellow thing over here is the median, because this divides my road into the left lane and the right lane. So likewise, in a statistical distribution, the median is that number which distributes my distribution into two equal halves. So formally, to define it, the median would be that measure of central tendency that cuts my distribution into two equal parts. So to locate the median, so like the mode, you can also just do a casual inspection, but in some cases it makes sense to use this formula n plus 1 by 2, which gives me the position of the median. Here n is the number of data points in your distribution. So let's take two cases. Case 1, where I have an odd number of data points. So like I said earlier, so the important thing in the calculation of the median, or to find out what is the median, the thing that you have to keep in mind is you have to arrange your data points in either the ascending order or the descending order. Only then you go in for the calculation of the median. So my data points here are arranged in the increasing order, so that part is taken care of. So now I'm just going to find out what is the median here. So I go through my data points and I see that 17 lies exactly halfway between this set of data points. There are 3 points before 17 and 3 points after 17. Therefore 17 is my median in this case 1. Now that's not all that quite straightforward when I have an even number of data points, wherein I have 8 points over here. So if I do a casual inspection, I'll see that both 17 and 18 are at the middle of this distribution. There are 3 points below 17 and 18, and there are 3 points after 17 and 18. So it makes sense to use this formula over here to calculate my median. So my n here is 1, 2, 3, 4, 5, 6, 7, and 8. So I take 8 plus 1 divided by 2, which becomes 9 by 2, which is 4.5 over here. So my median is somewhere between, the median is exactly halfway between 17 and 18. And the number that lies exactly halfway between 17 and 18 is 17.5. Therefore, my median in this case is 17.5. Right, moving forward. The last measure of central tendency, which is my, I have clicked on something wrong over here. Right, okay. So my last measure of central tendency, which is the mean. So the mean is the most commonly used measure of central tendency, and this is simply obtained by adding the given set of scores and dividing by the number of scores in that given data set. To define it formally, the mean could be defined as the sum of set of scores divided by the total number of scores in the set. So the mean is given by this symbol over here, x bar, which is, so the mean is x bar, which is defined by the summation x divided by capital N. This has to be capital N. Summation x divided by capital N, where capital N is the total number of scores in the set, and x is the raw score in a set of scores. And the symbol sigma refers to summation. Right. So some characteristics of the mean. So unlike the mode, the mean is not the value that occurs the maximum number of times. Also, unlike the median, the mean is not necessarily at the middlemost point in your distribution. So if you really need an analogy, think of the mean as a center of gravity as the point of balance in your given distribution. So in order to explain this concept of center of gravity, we need to talk in terms of the deviation. So the deviation is the distance and the direction of any raw score from the mean. So we've already defined what is the mean. X bar is summation x by n. So my x bar, this is denoted over here. So if I want to find out the deviation, I need to make use of the formula x minus x bar in order to arrive at the deviation. So let's try and work out a problem over here in order to understand what this thing called deviation really is. So let's just consider this first half of the table, just the first column over here. So I have 5 points in my data set over here, 9, 7, 6, 5, and 3. And I want to find out the mean first. So in order to find out the mean, I need to use this formula. X bar is summation x by n. Summation x in this case is summation of 9 plus 7 plus 6 plus 5 plus 3, that is 30. And I have 5 different data points over here, so my denominator becomes 5. So 30 divided by 5 is 6. So my mean in this case is 6. Arithmetic mean denoted by the symbol x bar, that is 6. Now I want to find out the deviation. So I fix the mean, which is the 6, as my center of gravity or as the point of balance. And then I move upward, and then I move downward, and then I find out by how many units are the values above and below deviating from my mean. So let's go up first. Let's start with 9. So 9 is 3 units above 6, therefore my deviation here is plus 3. So x is my value over here, which is 9, and x bar is my mean. So 9 minus 6, that becomes my deviation value for this raw score. Likewise, 7 is 1 unit above 6, therefore my deviation here becomes plus 1. Likewise, I go down below my mean value. 5 is 1 unit below 6, so my deviation value becomes minus 1. Also, 3 is 3 units below 6, so my deviation value here becomes minus 3. So I've arrived at deviation here. So what's the big deal about it? So the big deal here is that you find that the values above and below my mean, they are equal to each other if you disregard the sign. That is the absolute values. 3 plus 1, 4, 3 plus 1, 4. So these values are equal to each other above and below my mean. So with that, I hope we have given you some clarity on the usage of the terms, the mode, the median, and the mean. So this was the book that we referred to in order to create this screencast, and that brings us to the end of this screencast, and thank you very much for watching.